Now we finally reached the human brain. No doubt you've been waiting for this all along, because cognitive science questions are frequently assumed to be answered by brain kind of answers. I want to be more cautious than that. I want to suggest to you that the brain is not something that we understand, not something that we have a firm grip on. We are learning a lot about the brain, but as we do so, our view of who we are and what we are will change, and it is very, very early days yet. It is not yet clear how we should approach the brain, in what way we should understand this obviously very significant organ of the body. There are theoretical frameworks that interpret it one way, and theoretical frameworks that interpret it another way. The diversity of approaches stems from the fact that we're not quite sure what questions to ask of the brain, and what we should perhaps avoid asking of the brain, because not every question you can think of can be answered with a brain-like answer. The brain is unquestionably an organ of the body. The questions we have about brains, however, often extend far beyond concerns that are obviously about the body. Our lived experience, our qualitative, rich, full lives as living, thinking persons, these are facets of our being that we have questions about, but they don't necessarily admit of brain-like answers. So how do we go about finding out about the brain? And bear in mind that intense study of brains is very, very young. Maybe 150 years old, really. Not more than that. Well, there's a variety of roots in here. Some very important lessons have been learned from studying pathologies, things that happen when things go wrong, trauma, damage, disease, tumors, that kind of thing. There are recurring pathologies that we get very familiar with, things like Alzheimer's disease, for example, which are clearly a malfunctioning of the brain. And there are also pathologies that we suspect might be brain-based or that are not, where a lot of controversy arises. So the degree to which, for example, questions that arise in the area of mental health, the degree to which they admit of brain-based answers is still very, very controversial. We can learn a lot from animals, and we are much freer to study the brains of animals than we are the brains of humans, which is appropriate, I believe. And recently there's been an enormous proliferation of new imaging technologies, which have provided us with interesting new ways to consider what's going on in the brain. But as we'll see, they don't unlock the secrets of the brain. The brain is and remains very enigmatic, but they give us an awful lot to think and talk about. And perhaps most study of the brain has been done entirely indirectly by drawing inferences from behavioral studies or other forms of scientific inquiry that we've already met. But that indirect attribution to the brain often depends on a fixed and perhaps unquestioned notion of what it is that the brain is actually doing, which I'm suggesting is not yet clear. There's a lot of interesting, important and good science here, but I want to start off with some bad science, I'm afraid, some really, really bad science. If we go back 200 years, 250 years, we will find a discipline known as phrenology. Phrenology is not a respectable scientific discipline, so please don't believe I'm selling it to you, but I think it's very important for us today, nonetheless. Phrenology has a very sensible basis, and it lies on the old assumption, which we've met several times in this course, that in understanding something as complex as a person, we might understand different kinds of capacities, different kinds of skills and abilities independently of each other. So we might study language without studying the motor system, for example, or we might study reasoning without appeal to the emotions. And we know that this is problematic, but it's a very, very old idea, and it gave rise to the idea that we had distinct psychological faculties. So the faculty of reason is one, and the faculty of language. But pinning down what those faculties are has always been difficult. Well, phrenology went to town on this notion of separate faculties, which we met incidentally in the modularity of mind hypothesis from Jerry Fodor. Anatomists were only coming to terms with the brain, and they knew that it had distinct parts. One way to interpret this was to believe that the brain was actually a collection of distinct organs, each one subserving a different faculty. Franz Josef Gall is a Swiss anatomist who's particularly associated with this. He would have reached his peak about the year 1800. And for Gall, there was probably about 27 different organs in the brain, and they were associated with different faculties. And now we're in the embarrassing situation, which we still find ourselves in, of not being clear which faculties we're talking about. So phrenology made some imaginative leaps to assume what those faculties were. Two of them here, which you might question: the carnivorous instinct and the poetical talent. I'm not sure we would really look for a brain-based explanation of either of those questionable things now. There's a phrenological map. You notice they're drawn on the outside of the skull. This results from the idea, itself not particularly misguided, which if the brain were an assembly of different organs, and these organs had different strengths or were exercised more, like muscles, that those that got more exercise or were better developed would be bigger. And here phrenology made a very problematic leap of imagination, which is that if different parts of the brain have different sizes from individual to individual, then perhaps by feeling the bumps on the skull, we could interpret their psychological makeup. That is, of course, complete nonsense. Well, that's why these drawings from early phrenology have areas sketched on the outside of the head, because they used to feel the head to identify, well, the faculties. What were the faculties? Nobody could ever agree. Here in this phrenological map, we get amativeness, so capacity to engage in love, combativeness, benevolence, hope, wonder. These are fine words. They don't make well-defined objects for scientific investigation as laid out like this, though. So phrenology is dead. It's gone. By 1850, nobody was a phrenologist anymore, and phrenology has been thoroughly discounted. But there's a very important lesson to be learned from phrenology. Those proto-scientists were very keen to articulate a function, the capacity for wonder, and to associate that function with a place in the brain. And that gives a reassuring sense of understanding, which is built out of absolutely nothing. So if we associate a function with a place, we get this idea that we're learning that difficult organ, the brain, and we can be entirely fooling ourselves as well. This notion of function turns out to be very problematic. The reason this is still a very urgent question for us today is because we keep repeating this mistake. The attribution, simplistic attribution of a specific function couched in high-level terms with an innocent part of the body persists to this day. And we'll encounter that danger again. It's always going to be lurking in the background. So we noted that there are various sources of information, real sources of information rather than speculative, like here. And pathology was one of those. And the most famous case here in the literature is probably this of Phineas Gage. Now, this is a case which is about 150 years old. That's Phineas Gage there, clutching his tamping iron. You may have heard of his story. He's very, very famous. And he's one of what became a series of landmark cases, which we learn about because they illustrate not so much an answer to our questions, but they help us to formulate our questions. Every pathological study, every study of a pathology has several limitations. These are never controlled studies. As we'll see, Phineas Gage had an accident and it did some damage. And drawing consequences from that is very difficult, because an uncontrolled chance occurrence like this is not careful which parts of the brain it damages. So we get a unique caseload that doesn't necessarily generalize. And of course, because we're dealing with pathology, we're already looking at a broken system. If you show someone who knows nothing about cars a broken car, they're not going to be in a good position to figure out how a real car works, a functioning car. Anyway, let's discuss Phineas Gage. Phineas Gage was working on the railroad. He was a foreman of a gang who were working in Vermont in the United States. And what they were doing, they were blasting some rock in order to lay down some tracks. And to blast a rock, what you do is you drill a big hole and you put in some gunpowder, and then you tamp it down with a big rod called a tamping iron, which you just saw Phineas holding. And after that, then you stick in a plug and a fuse, and you retire to a safe distance and you light the fuse. But it was in tamping down the gunpowder that Phineas Gage unwittingly caused a spark, which caused the gunpowder to prematurely detonate, which drove the tamping rod out of the hole and in above his left eye here and out through the top of the skull, and it landed several yards behind him. Ouch. It's not clear whether he even lost consciousness in this. What is clear is that he did himself a substantial amount of damage. That's his actual skull you can see there. You can see the hole in the skull, and you can see a computer recreation of the path that the tamping iron took. He wasn't out of action terribly long. He returned home from hospital 10 weeks later, but there were changes. There were problems with Phineas Gage. So after the accident, his co-workers noted that his personality seemed to have changed. He was well known as a very capable and efficient foreman. He was capable of making good decisions. He was easy to get along with. And after the accident, he was changed radically. He was described as profane, irreverent, fitful. He was a problem to work with, got into arguments, and he wasn't any good at planning. So that expression, he was no longer Gage, is worth thinking about. What is a personality? It's not a simple thing, for sure. To say that this singular event damaged his personality gives us an awful lot of things that need filling in there, doesn't it? That on top of the tamping iron, he became famous precisely because he allowed this question to emerge. This was the first well-documented case where a well-located destructive act to the left frontal lobe resulted in an associated high-level change to the personality, and the medical profession was just becoming interested in the possibility of this, so doctors took a keen interest in his case. He was one of the very, very first in which there was this link between a well-documented injury and a high-level change in something to do, well, that was of interest to the psychologists, I suppose. With this, it kicked off renewed interest in understanding the brain as an organ with diverse areas subserving different functions. And it led to, we hadn't learned our lesson from phrenology, it led to an indulgent elaboration from that basic idea, which found some of its worst excesses in the practice of lobotomy, which was a form of surgical technique used for problematic patients in psychiatric institutions, in which basically the injury of Phineas Gage was brought on deliberately by inserting needles through the top of the eye and reducing the local brain to mush. This was practiced for decades in psychiatric institutions. It is no longer so done. But you can see that when we start to decide on how we're going to interpret the brain, the consequences are not always what we see. Now, the part of the brain that Phineas Gage had damaged is worth attending to. This is the frontal lobe, which we've met before. The frontal lobe is a very mysterious part of the brain. It's also the largest part of the human brain, and the largest frontal lobe of any animal belongs to the human. It's also that part of the brain that has a very, very long developmental stage, taking anything up to about 20 years to develop. It's also the part of the brain that's furthest removed from any direct connection with the world through the senses or muscle effectors, especially the prefrontal part, that part that's just above the eyeballs there. For this reason, from inferences from Phineas Gage and others, and because of its remoteness and its particularly human character, the frontal lobes are often described as the seat of higher cognitive functions like reason and deliberation and personality. But that leaves an awful lot to be explained. You remember your neuroanatomy, we looked at the 4 lobes of the cerebral cortex on each side. We're talking here about the frontal lobe, and in particular, the frontal lobe divides more or less into 2 areas. The prefrontal area, this is the area that Phineas Gage damaged, is right here above the eyeballs. And then as we go back, the back part of the frontal lobe is more directly involved in movement. So we get the primary motor cortex there, and so on. It's worth finding out about the brain, finding areas, and when you see the brain discussed, having a look at what that area is. Here's a little free software platform you can download and play with on your computer, and it's called Brain Tutor, and it allows you to identify anatomical areas in the brain if you happen to read about them, to zoom through the brain in a variety of different formats, and it's freely available for all platforms. I've had good experience playing with it, and I recommend it to you. Right,